solve d cube minus 3d d dash square plus 2d dash cube into z is equal to e power 2x minus y plus e power x plus y. Let us see how to solve this problem. First, you have to write the auxiliary equation. Auxiliary equation. How to write auxiliary equation? For d, you have to write m. For d dash, you have to write 1. So therefore, for d m cube minus 3m plus 2 1 cube d dash square 1 square, which is equal to 0. So m cube minus 3m plus 2 is equal to 0. So if you factorize this m cube, so you have to take the trial and error method. If I am taking m is equal to 1 cube minus 3 into 1 plus 2, which is equal to 0. So it gives 0. So that's why m is equal to 1 is the one of the root. So therefore, using synthetic division you can solve. M cube coefficient is 1, m coefficient is minus 3, constant term is, there is no m square, so that's why 0 m square minus 3, constant term is 2. So this is a synthetic division. M is equal to 1, you have to take here 0. If you are adding this 1, if you multiply 1 into 1 will be 1, 0 plus 1 1, 1 into 1 1, minus 3 plus 1 minus 2, minus 2 into 1 minus 2, so 0. So m square plus m minus 2, which is equal to 0. The cubic equation will be reduced to quadratic equation. So quadratic equation you can easily solve. M plus 2 into m minus 1 is equal to 0. Okay, so m is equal to 1 comma minus 2. Totally cubic equation, there should be 3 roots. So therefore m is equal to, already we have got 1 minus 2. So this is the root of m value. Okay, so m is equal to 1 minus 2. Now you have to write the complementary function. So how to write the complementary function? Let us see. So the complementary function is the complementary function. The complementary function is two roots are equal. Okay, so therefore z is equal to phi 1 of y plus x plus x into, why I am writing here x, two roots are equal, phi 2 of y plus x plus phi 3 of y minus 2x. So there are 3 roots, so we have to write the 3 roots. So this is the complementary function. There are 2 particular integrals. First particular integral 1 is 1 divided by d cube minus 3d d dash square plus 2d dash cube, 2d dash cube into e power 2x minus y. Now if there is e power 2x minus y, for d you have to substitute the coefficient of x. D dash you have to substitute the coefficient of y. So you must understand coefficient of x, coefficient of y. So what is d? Coefficient of x is 2. What is d dash? Coefficient of y is minus 1. This is very important. So you have to substitute here 1 divided by 2 cube minus 3 into 2 into minus 1 square plus 2 into minus 1 whole cube e power 2x minus y. So now you have to multiply 1 divided by 8 minus 6 minus 2 e power 2x minus y. So denominator will become 0 e power 2x minus y. So if denominator is 0, the ordinary rule fails. So therefore multiply, when ordinary rule fails, you got to follow this method. So multiply x in the numerator, differentiate denominator. dr means denominator. So we have to multiply x in the numerator. So x divided by d, only you have to differentiate d cube. If you are differentiating 3d square, d if you are differentiating 1, so minus 3d dash square, right? 3d dash square into e power 2x minus y. Again for d2, for d dash minus 1, so x divided by 3 into 2 square minus 3 into minus 1 square e power 2x minus y. Okay, so now you know very well e power 3 into 2 square will be 12. So which is equal to particular integral 1 x divided by 2 into, so 3 into 2 cube, 2 square, so 4 minus 3 into minus 1 square will be plus 1. So e power 2x minus y. Okay, so next step, which is equal to x divided by 12 minus 3, so e power 2x minus y, which is equal to x divided by 9 e power 2x minus y. So particular integral 1, which is equal to x divided by 9 e power 2x minus y. This is particular integral 1. Next you have to find the particular integral 2. So how to find 1 divided by particular integral 2 is equal to 1 divided by d cube minus 3d d dash square plus 2 into d dash cube e power x plus y. So for d you have to apply 1, for d dash you have to apply the coefficient of y. Coefficient of y is also 1. So therefore which is equal to 1 divided by 1 cube minus 3 for d1, for d dash 1 plus 2 d dash 1 cube, right? So e power x plus y. So therefore which is equal to 1 divided by 1 minus 3 plus 2 e power x plus y, which is equal to e power x plus y divided by 0. So ordinary rule again fails. So we have to go for the x, multiply x in the numerator, differentiate denominator, multiply x in the numerator, differentiate denominator. That rule we are going to use. So therefore particular integral 2, which is equal to x divided by 3d square, d only you have to differentiate, 3d square minus 3d dash square e power x plus y. So therefore which is equal to x divided by 3 into 1 square minus 3 into 1 square e power x plus y. Again it will give x into e power x plus y divided by 0. Ordinary rule again fails. So you have to differentiate here, differentiate denominator. In the numerator you have to multiply by x. Already there is x. If you multiply x, again x square. Suppose you have to take this as equation number 1. Equation number 1 you have to multiply x in the numerator, differentiate denominator, x square 6d. There is no other terms. So 6d. So x square 6d, which is equal to x square divided by 6 into 1 e power x plus y, which is equal to, so particular integral 2 is equal to x square divided by 6 e power x plus y. This is particular integral 2. So therefore general solution is general solution is CF complementary function plus particular integral 1 plus particular integral 2. So therefore z is equal to phi 1 of y plus x into phi 2 of y plus x minus plus phi 3 of y minus 2x plus x by 9 e power 2x minus y plus x square by 6 e power x plus y. This is the general solution.